Welcome to Want to Learn Chemistry, a site to help you become a chemistry expert. Today you'll be learning about the extraction of copper. As a starter activity, identify what do the objects have in common. For extension activity, list the properties that make them useful for their purposes. So let's go over the answer. These pictures are all showing copper. And the properties that make copper useful for their purposes is that they are ductile, malleable, easy to shape, they are good conductors of electricity, and many more. Extracting copper from copper-rich ores. Most of copper is extracted from copper-rich ores. However, there are limited resources and we are in danger of running out. There's two main methods to removing copper from copper ore. First is sulfuric acid, which is used to produce copper sulfate solution before extracting the copper, and second is smelting. Smelting is when we heat the copper sulfide in a furnace until it decomposes to form copper metal and sulfur dioxide. Below are the word equations and symbol equations. Problems with smelting. Smelting produces sulfur dioxide, which causes acid rain. Care has to be taken to let it out into the atmosphere, so chimneys are fitted with scrubbers to neutralize the acidic gas. Even after the copper ore is being smelted, you still need to use electrolysis to get higher purity, and this process uses a lot of energy. During electrolysis, we have positive ions, which are cations, which travel to the negative electrode, known as cathode. The negative ions, known as anions, travel to the positive electrode, known as anode. Metal ions are always positively charged. In electrolysis, they are attracted to the negative electrode, so metals are always deposited at the negative electrodes. In industry, electrolysis is carried out in many cells running at once. This method gives very pure copper needed to make electrical wiring. Electrolysis is used to purify the impure copper extracted by smelting. In the process, the cells use copper electrodes. Iron can be used to extract copper from copper sulfate, as iron is more reactive than copper. This diagram shows electrolysis. We have copper sulfate solution here, copper anode and copper cathode. Here is impure copper, and during the reaction the impure copper is made pure and goes to the cathode. Question: what chemical do we use to treat copper ore in order to form copper sulfate? And the answer is sulfuric acid. Extracting copper from low-grade copper ores. Scientists are developing new way to get copper from low-grade ores instead of extracting copper from our limited copper-rich ores. This would be uneconomical using traditional methods. We can use bacteria, and the method is known as bioleaching, and plants, and the method is known as phytomining, to help extract copper. Greener methods. Copper-rich ores are running out. We need to go after the low-grade ores, but they're not worth mining the old-fashioned way. Therefore, we need someone to do the work for us. And this is where plants and bacteria come in. Phytomining, plants grown on copper sites, they take up copper into roots. We burn them and get the copper. Bioleaching, bacteria naturally oxidizes metal sulfides to the metal. We can farm them to do this job for us. Bioleaching, copper ions can be leached, i.e. dissolved from the ash by adding sulfuric acid. This makes a solution of copper sulfate. Then displacement by scrap iron and electrolysis can be used to extract pure copper metal. The bacteria feeds on low-grade metal ores. Combining biological and chemical processes, we can get a solution of copper ions from waste copper ores and use scrap iron and electrolysis to extract the copper from the leached solution. Phytomining. Plants can absorb copper ions from low-grade copper ore as they grow. This can be on slag heaps of previously discarded waste from the processing of copper-rich ores. The plants are burned and the metals can be extracted from the ash. So, you need to remember three main processes of extracting copper. First is smelting, second is phytomining, and third is bioleaching. Evaluate and contrast the pros and cons of smelting versus phytomining and bioleaching. Now let's go over some of the pros and cons. Smelting, a pro is that it's quick. We can obtain a lot of copper and we can use the best copper ore. However, the con is that it requires a lot of energy and it's not environmentally friendly. Phytomining and bioleaching are more environmentally friendly. We can go after the not so good copper ores, so we're making use of all that is available to us. We don't have to do all the work. However, it does take time to set up. And all of these methods still require electrolysis to get pure copper. Answer the following questions to check your understanding. And this is the answers to the questions. Copy and complete using the words below. More questions, summary questions to help you to check your understanding. And these are the answers to the question. More summary questions. And let's go over the answers. Thank you for listening. You have been listening to me at Want to Learn Chemistry, a site to help you become a chemistry expert. Like and subscribe for more videos.